Hey guys, we're back at it again. We're doing lesson 6 today. This is what you guys are working on for Tuesday. Tomorrow you guys are going to be doing the practice problems. The SAT is also going on, so I didn't want to give you guys a whole lot since my juniors are going to be out if they're an avid. So this is talking about the volume of cubes. You guys know the basic idea of volume. Volume is length times width times height. So we're going to go through and do one of these really quick. We know the volume is going to be length times width times height. And you guys know that these are all 2. 2 times 2 times 2, or 2 cubed, or 8. I want you guys to please go through and solve the rest of these for me. Go ahead and try those out. All right, after you guys finish that, what we're going to do is go on to the second part. This is now talking about surface area and volume when you do a scale factor, okay? The volume is pretty straightforward. The surface area might not be as straightforward as we could see it. What I'd like to do is go through and draw out a basic kind of cube. Basic cube starts out like this. Doesn't have to be perfect. We have our basic cube. This cube is made up of 6 squares, all having the same area. And it folds up like so. You take each of these pieces, fold them over, and you guys can get a shape like that. There are 6 of these. We know how you find a square is you take side times side, or side squared, and then there's 6 of these. So when you guys are looking at this, you want to think about 6 times s squared. Okay? As for the volume of the cube, I'm going to leave this part to you guys. First, if we take the volume, we take 1, 1, 1. And so 1 times 1 times 1 quite literally gives us 1. As for the second part, however, we're taking a scale factor and we have to multiply every single one of these by k. In the second row, this is going to be 2. So think about how that's going to change the volume. And what I'd like you guys to do is please go through and find each of these. I gave you guys a little too much information on the surface area, but what I'd like you guys to do is please go ahead and think about the rest of it. Remember, when you guys use a scale factor for the surface area, we're taking each of these sides, side times side, and we're multiplying them by k. So keep that in mind when you guys go through to do this. And it's going to start to make quite a bit of sense. Okay, so please go ahead and finish off all of 6-2, all the questions that go with it. And then we're going to go ahead and move on to 6-3. Go ahead and press pause, finish off this problem. All right, here's on to the last part. This part's a little bit wordy, so we're going to go through and read it. As you guys just saw, when you dilate a cube, the volume is multiplied by k cubed. It seems that must apply to all solids, but I'm not sure how to prove it. Elena says, earlier in the unit we showed that we can cover any two-dimensional shape with rectangles. So the property that area changes by k squared, then we dilate a figure by k applies to all shapes, not just rectangles. Can we do something similar here? Use Elena's line of reasoning to argue that for any solid, if it's dilated by a factor of k, the volume's multiplied by k cubed. What I'd like you guys to do is please go through and think about when you guys draw any solid. We can do a rectangular prism. That's an easy one to do. We could draw out a rectangular prism. Think about this one as well. How would this work? What's the area formula for this, or the volume formula for this? how would it be affected by scale factor k? I also want you guys to think about a triangular prism. Okay, think about the volume and how a scale factor multiplying each of these sides change. Then I also want you guys to think about a sphere. So you guys have the first part of the sphere, the back part, and then you guys are also going to have the part that comes out this way. I am not the best at drawing a sphere, but imagine a ball. It kind of looks like I drew some sort of seed. But you guys know the volume of a circle, or the volume of a circle, the area of a circle is pi r squared. In this case, how would this be affected as well? Hi.
Do you want me to take this tray
All right.
for you?
Yeah.
Yes, please. Okay.
All right, guys. Have a great day. Bye. Well, excuse me. Go and answer problem number 2 here, and then you guys are done with this lesson. Have a great day, guys. Bye.